We've seen before, a measurement is composed of three parts: value, units, and uncertainty. In particular, the uncertainty gives us a lower limit and an upper limit for the value. Now we could ask ourselves, how many figures should we be using for the value? How many are enough? There is uncertainty, so the significant figures are those figures that reflect the measurement uncertainty. Take this sentence: Charlie's height is 6.09 plus minus 0.02 feet. Since the uncertainty is 0.02, which means on the second decimal figure, we can trust both the 0 and the 9 after the decimal point. So in this case, 6, 0, and 9 are all significant figures. Let us now assume that the sentence above said Charlie's height is 6.09 feet. What may we conclude on this information? This sentence might imply a certain uncertainty. For example, it might imply the uncertainty to be 0.01 feet, but we do not know what the actual uncertainty is, so we cannot make up one. So the second sentence is meaningless, because we have no idea of how many figures we can trust, if any. For example, if the uncertainty was 1 foot, then we could trust the 6, but not the 0 and the 9. Now you might ask yourselves, in a problem, the numbers are not given with the uncertainty, so should we trust them? For the purposes of this course, we'll assume all those figures are significant. But if the same sentence with uncertainty missing was found on a lab report, then we would have a problem. The take-home message is that the number of significant figures must be consistent with the actual uncertainty on the value. It cannot imply a smaller uncertainty. Here's an example. On a notebook, you read, the specimen's leg measures 26.4214 plus minus 0.3 centimeters. Rewrite the length value in a way that is compatible with the uncertainty. From this example, we can see that the number of significant figures to keep in the value is not equal to the number of significant figures in the uncertainty, but rather the significant figures go up to the decimal position of the leading figure in the uncertainty, which is the first non-zero digit. In this case, that is the first decimal place. Okay, this is discussing one value at a time, but how do you combine multiple values, each one with their own uncertainty? Here is an example. I would like you to attempt this example before I give you any rules of thumb of any sort, just by using your intuitive understanding of what uncertainty means, so how it does set an upper bound and a lower bound for the value.